5 minutes probably. If you don't if you don't finish in time, you'll just take them home and add to homework. But you'll get to your Chromebook. I'll give you 10 minutes because you need some time to log in. So at 16. Cool. Students will be able to record the video. It's going. Simplify rational expressions. You have been simplifying rational expressions since the probably 4th grade, maybe 5th grade. I'm going to give you an example up here. I want to talk about it. If you have 2 plus 2 over 6 plus 2, how would I simplify that expression? Kieran? We're not going to cross cancel yet, but in like 4th or 5th grade, you learned this thing that was like PEMDAS, and you simplified grouping, and you did 2 plus 2 is 4, 6 plus 2 is 8, and then you'd like simplify 4/8, right? 4/8 could simplify to what? Some of us are a little quicker at doing this. Some of us will need to take time and pause and go back to some review. Addison, what would the answer be? Yeah, so you just simplified that basically all mentally. We're going to do the same process, but we're going to switch it up to some algebra. And you'll see why it's the same and why it's different. First off, a few notes. A rational expression is an expression in the form of a ratio or fraction. So if you have a ratio, it's going to have some line that's like a division bar or some fraction in it. Form of a ratio. So it looks kind of like a fraction, like you saw in that example we jotted down right here. Simplifying rational expressions is something you've done since 5th grade. It's just without variables. So if you have a rational expression like 15 over 20, I'm going to give you 2 ways of simplifying it. The first way over here, let's jot it down to the left. This is the way that we've probably learned since the 5th grade. And what did you do mentally, Addison, to go from 4/8 to 1/2? What were you actually doing? Did you do that process, or was it someone else? That was you, right? What did you do to both numbers 4 and 8 to get to 1 and 2? Yeah, you divided them by 4. And so we could do the same thing here. 15 won't divide by 20, but you could choose a number. What's the LCM of 15 and 20? Or it's the GCF, actually. We're not skip counting, we're just factoring. Colby, what would it be? 5 and 15 work, and 20 and 5 work. So let's divide both. That is the process equals 3/4. You guys have done since 5th grade, okay? On the right side, what happens if I do this? Let's factor 15. On the side, all the factors of 15 would be what, Tony? Okay.
So these are basically fractions, but they can't be called fractions because there's a variable. Is that it? Or are fractions and ratio things?
We're not going to call it a fraction. We'll call it a rational expression. Yeah. If it has, yeah, don't call it a fraction. It looks like a fraction. Yeah.
And basically they are because they're dividing.
Kind of. I don't know. Here's how we're going to set this up. So we just got the factors of 15. It's 3 and 5. Let's get the factors of 20. It's going to be 5 and 4. And I'm just going to stop there. I have 5 and 4. So let's put 4 times 5 right there. This is the same thing as this process. You just factored out both top and bottom. Could I cancel or cross-cancel something that would give me the same answer as 3/4 in this method? Colby, what would I do?
You cross out both 5s.
Sure, we could cross out the 5s and put 3/4 as the answer. This method is never taught in 5th grade. It is behind the scenes what's actually happening when you divide by 5. But it doesn't really matter because it doesn't come into play until you hit your 8th grade year in algebra. When we're simplifying rational expressions, we're going to think about our expressions in this method, and I'll show you why in a second. You're going to try to create 1 by identifying common where'd you go? Factors. This requires you to be really, really, really good at factoring, which is what we've been working on in the past 2 units. So let's look at an example that's actually going to pop up on a test. X squared y at first unprofessional. X squared minus 3x minus 10. We're going to look at that trinomial and we want to factor it into 2 binomials. So let's go ahead and factor it. Just like we kind of factored the 15, you can factor a trinomial too. What is the 2 numbers that multiply to negative 10? Add to negative 3. Sarah? Negative 5, positive 2 would work. Great. We just simplified it. We factored out 2. What are the 2 numbers that would multiply to negative 25 and have no middle term? Kieran? Yeah. It doesn't matter where we place them. Notice I'm going to put the negative 5 somewhere kind of strategic for these. So I have an x minus 5 and x plus 5 on bottom, x minus 5, x plus 2 on top. Just like we crossed out the 2 factors of the 5 and the 5, what 2 things could I cross out in this problem, Addison? This entire binomial. When we're working with algebra, this thing is a term. X minus 5 is a whole term. X minus 5 is a whole term. I can't just cross out the x and just cross out the x. This thing is actually one giant term. It is a binomial. They're looped together, so we're going to cross out the entire thing, and you're left with x plus 2 over x plus 5. That is our answer. Sarah? Great question. Let's write the answer here and see why I may not be able to do that. If you had x times 2 and x times 5, you could cross, if it was like that, you could cross them out. You can't cross it out if it's an x plus a 2. Just the same reason why you couldn't cross it out if it was 7 plus 1 and 7 plus 2. You can't cross out the 7s. If it was 7 times 1 and 7 times 2, that works, but this is a whole term. You can't cross out the 7s if they're added. Don't cross out the x's if they're added. Next page. 25x minus 125, x squared minus 25. First thing you're doing is factoring. Factor the top for me, Elliot. It's not a trinomial, but I can factor out one number. What would I pull out of here? I'm going to go one higher number too. Does 25 go into 125? I think 25 goes into 125. So let's factor out the greatest one, and let's pull out the entire 25. 125 divided by 25 is 5. Let's factor the bottom. X squared can factor into 2 binomials. Kylie, what 2 would work? X minus 5, x plus 5. Is there a binomial I can cross out? Sure, cross out the x minus 5, cross out the x minus 5, and you get 25 over x plus 5. I cannot cross out the 5 and the 25 because x plus 5 is an entire term. This whole thing is lumped together. I cannot cross out the 5 with the 25. This would be my answer. X plus 5 is an entire term. You cannot cross it out unless it's exactly the same on top. Let's do one more, then we'll switch to a partner one. Tony?
Can we just solve this in our head though? If we crossed out the x squared with the x on top, and then that left just one x, and then we divided the 125 by 25. Can you just done that and then left the 25
Yeah,
x?
I see what you're doing. I don't think so. You're using product exponent properties of exponents, and the x crosses with the x squared. Leave that thought to the side. I'm not gonna make that a habit, but you can like kind of play with that when you get to bronze and see if it works. Example 3, 2x squared minus 12x. Factor the top as simple as you can make it. Sarah, what would I do? Okay, silent yes if you agree with that factor, silent no if you disagree. Sarah disagrees with herself. Oh, dang it. Mark one blender, but that's not the one that I wanted to actually mark. There is still something in here that's a blunder. Take 10 seconds to look at it. I factored out a 2. What am I missing? Mackenzie? Beautiful. The 2 and the x can be pulled out because there's a 2, there's an x in both terms. 2x would turn into x on the inside minus 6. X minus 6. Cross out the x minus 6 and x minus 6. It leaves 1 and 1 really, which is just 2x over 1. If you have any number or variable over a 1, it's just itself. 2x is the answer. Last one. I have 9x to the 4th minus 27x to the 6th. What can I factor out of the top factor, Andrew? And 9x to the what? I'm going to pull out all 4 of these since that's the lowest number of the variable. So let's pull out 9x to the 4th. That leaves you with x. No, that doesn't leave you with x. What happens when I take out 9x to the 4th from a 9x to the 4th? Go ahead, Colby. It's just a 1. Anytime you have the same number top and bottom, it's just a 1. So that leaves a 1, and what happens to 27x to the 6th, Colby? Yeah. 27 divided by 9 is 3. X to the 6th divided by x to the 4th is x squared. That leaves a 3x to the 3rd down here. I do not have a binomial that I can cross out here, but I can cross out something here. Go back to your factoring unit or your exponent properties unit. And we're going to have a problem that looks kind of like this. 9 divided by 3 is 3. X to the 4th over x to the 3rd is quotient property. What do I do with the exponents? Wyatt? You subtract. 4 minus 3 is 1. 3x to the 1st is really just 3x. This crosses out. This crosses out, becomes 3x up here. 1 minus 3x squared stays there. There's nothing on the bottom. There's your answer. That is it. Tony.
If you would have crossed out 3x to the 3rd, but could you have crossed out 3x to the 3rd with negative 3x to the 2nd instead?
No, because this is a unit. This is a term. This is different than this. It's in parentheses, and there's an addition or subtraction sign in between. Yeah. It is different. Correct.
So you can only like cross out the ones that aren't added to the factor.
Yeah. Correct. That is the rule. You got 5 minutes. We're gonna switch 5 and 5, half partner and half silent, and then I'll get to your test when you're working silently.